So next topic of interpolation chapter, Lagrange's interpolation formula. This is the third interpolation formula. What is the first one? Newton's forward interpolation formula, and the second one is Newton's backward interpolation formula, and this is what? Lagrange's interpolation formula. So the first statement is what? Let y is equal to fx be continuous and differentiable n plus 1 times in the interval ab. This function is differentiable, and given n plus 1 values, what are that? X naught, f of x naught, that is the values of x are x naught, x1, x2, xn, and the value of the function y or fx are what? F of x naught, f of x1, f of xn, corresponding to this x naught, x1, x2, xn, where the arguments x naught, x1, x2, that is the values of x, are not necessarily equally spaced, that is equidistance. So in the previous two formulas, that is the Lagrange's, that is the Newton's forward interpolation formula and Newton's backward interpolation formula, the values of x are equidistant. So that condition is necessary in that two applications of the formulas. But in this formula, it is not necessary to equidistance point, that is this x naught, x1, x2 may or may not be equidistant. Not necessarily equally spaced or not necessarily equidistance means what? These values of x may or may not be equidistant. That is, if the values of x are equidistant, then we can apply Lagrange's interpolation formula. But if the values are not equidistant, then also we can apply the Lagrange's interpolation formula. The previous two, that is Newton's forward and Newton's backward, are not applicable if the values of x are not equidistant, and the use of these three formulas are same, that is to interpolate the value of the function fx if the table is given. So note here that these values of x, that is x naught, x1, x2, are not necessarily equally spaced, not necessarily equidistant. That means may or may not be equidistant. And what are the values of the function corresponding to x naught, x1, x2, xn? F of x naught, f of x1, f of xn. These are the values corresponding to x naught, x1 to xn. So it started from, the value started from x naught, x1, x2, xn. That is, these are in n plus 1 numbers. These values of x or fx are what? In n plus 1 numbers. So it started from, the number started from 0, 1, 2. If we started from 0 and count to n, then these numbers are in n plus 1 in number. And these values of x are not necessarily equally spaced. So this is the set. So in the previous two, the values are equidistant. The values of x are equidistant. And so if the first value is a, then the second value is a plus h, then the third value is a plus 2h. That is, if we know the first value, then we can find further values by adding h. But here the values of x are not equidistant, and therefore are denoted by x naught, x1, x2 instead of a plus h, a plus 2h. When we can denote the values of x as a plus h, a plus 2h, if the values of x are equidistant. But if the values are not equidistant, then we cannot write the values of x in that form, that a plus h, a plus 2h. And so here the set of the points is what? Is x naught, f of x naught, x1, f of x1. That is, the first value of x is x naught, the second is x1, the third is x2, the fourth is x4, x3, in this way. So this is the set of the given values, or this is the table. That is, if we write these values in form of table, then the first row is values of x, and the second row is the value of y or fx, and the values of x are what? X naught, x1, x2, xn, and the values of y are f of x naught, f of x1, f of xn. That is the second row. So this is the given, and we define the function fx in this form. then we define the function fx in this form. So what is the function? Coefficient of a naught is x minus x1, x minus x2, x minus xn. That is x minus x naught is not the coefficient of a naught. Then what is the coefficient of a1? Is x minus x naught, x minus x2. That is x minus x1 is not the coefficient of a1. X minus x naught is the not coefficient of a naught. Similarly, x minus x1 is not the coefficient of a1. Similarly, what is the next term? If you write next term, then a2, it is what is the coefficient of a2? X minus x naught, x minus x1, x minus x3. That is x minus x2 is not coefficient of a2. In this way, the coefficient of a3 does not contain x minus x3. And in this way, what is the coefficient of an? So delete this x minus xn term. What is the coefficient is x minus x naught, x minus x1, x minus xn minus 1. That is x minus x1 is not the coefficient of an. So this is fx. So write this fx. Right here one more term a2. What is a2? Coefficient of a2 x minus x naught, x minus x1, x minus x3 dash 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 x minus xn. So right here one more term for convenience, where a naught, a1, a2, an are constants and are to determine. We have to find the values of these a naught, a1, a2. So in order to determine the values of a naught, a1, a2, an, substitute x is equal to x naught, x1, x2 dash 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 xn in this 2.8 successively, and we get, that is, first substitute x is equal to x naught. Then what is the LHS? F of x naught is equal to a naught, and here substitute x as x naught minus x1, x naught minus x2, x naught minus xn. And what is the coefficient of a1? If we substitute x is equal to x naught, then this value of this bracket is 0, and so coefficient of a1 becomes 0. That is, this term becomes 0. Similarly, the coefficient of a2 is 0. Similarly, the coefficient of an, that is, this term is 0, means this term is 0. So all remaining terms are 0, and therefore we have this. And then what is a naught? A naught is f of x naught divided by all these brackets, that x naught minus x1, x naught minus x2, x naught minus xn. Similarly, substitute x is equal to x1 in this. So what is f of x1? LHS f of x1 is equal to a naught. The coefficient of a naught is 0 because x1 minus x1 is 0. Value of this bracket is 0. What is the coefficient of a1? x1 minus x naught, x1 minus x2, this, and then x1 minus xn. And what is the coefficient of next term? a2 is again 0. The coefficient of an is 0 because this bracket is 0. So coefficient of all the remaining are 0, and therefore we have this. And from this we have a1 is f of x1 divided by all these bracket, that x1 minus x naught, x1 minus x2, x1 minus xn. Okay, this is a1. Similarly, if you find a2, what is a2? F of x2 divided by x2 minus x naught, x2 minus x1, x2 minus x3, x2 minus xn. a2. What is a2? F of x2 divided by x2 minus x1, x2 minus x1, x2 minus x3. Don't write x2 minus x2 because the coefficient of a2 does not contain x minus x2 term. Then x2 minus xn. Similarly, what is an? Is f of xn divided by xn minus x naught, xn minus x1, xn minus x2. In this way, xn minus 1. Because if you observe the coefficient of an, then this is what last term is x minus xn minus 1. So this is an. And substitute all these values in equation, all these values of a naught, a1, a2, an, equation 2.8. So what do we have? Fx right here, a naught, this value. Then right here a1, this value, and there here an, we have this. What is by after adjustment? So what is value of actually a1? F of x naught divided by this, and into this, into this, that x minus x1, x minus x2, x minus xn. So arrangement of these terms, we have this x minus x1, x minus x2, x minus x naught divided by x naught minus x1, x naught minus x2, x naught minus xn, f of x naught. Then similarly, plus after substituting value of a1, we have this x minus x naught, x minus x2, x minus xn divided by x1 minus x naught, x1 minus x2, in this way into f of x naught. Now f of x1. Similarly, substituting value of a2, we have this, and substitute the value of an, we have this. So this is the Lagrange's interpolation formula. So what is the coefficient? What is the first term? Here is no x minus x naught term. Here is no x minus x1 term. Here is no x minus x2 term. Here is no x minus xn term. So divide by what? X naught minus x1. So just write x as x naught, x as x naught, x as x naught. Here is just write x as x1. Then x1 minus x naught, x1 minus x2, x1 minus xn. So just write here x2. Here is no x minus x2 term. So x2 minus x naught, just write x as x2. Okay. So all the remaining terms are, and here is no x minus xn term, just write x as xn into f of xn. So this is the Lagrange's interpolation formula. So these are some examples on the Lagrange's interpolation formula. The first is what? The table is given. So table is given in the form that f of 1 is 2. That is, prepare the table. First, what is the given table? Values of x are 1, 2, 3, 4, 70. 1, 2, 3, 4, 70. And what are the values of the f of 1? Corresponding to 1 is 2. The corresponding to value is 4. Corresponding to 3 value is 8. Corresponding to 4 value is 16. And corresponding to 17 value is 128. So this is the given table. Actually, this is the table given in this form. And what we have to find? We have to find f of 5. That is, we have to find the value corresponds to 5. And 5 lies between 4 and 7. So this is the problem of interpolation. And here the question is using Lagrange's interpolation formula. If this is not given, only the question is find f of 5, then also we have to use the Lagrange's interpolation formula, because we cannot use the Newton's forward interpolation formula or Newton's backward interpolation formula for this problem, because the values of x are not equidistant. The distance between 1 and 2 is 1. 2 and 3 is what? 1. 3 and 4 is 1. But distance between 4 and 7 is what? Is not 1. Is 3. And therefore the values of x are not equidistant, and therefore we cannot use the Lagrange's we cannot use the Newton's forward interpolation formula or Newton's backward interpolation formula. You have to use Lagrange's interpolation formula. Here the instruction that in example use Lagrange's interpolation formula. If this is not given, only the question is find f of 5, then also we have to use Lagrange's interpolation formula, because when we use the Lagrange's interpolation formula, if the values of x are not equidistant, and the problem is of interpolation. So this is the problem of interpolation. So what is the meaning of interpolation? If these are the values, this is the given table, and we have to find the value of y or fx at 5, means the problem of interpolation. We have to interpolate the function at 5. So problem is of interpolation, and the values of x are not equidistant, and so we have to use the Lagrange's interpolation formula. So we apply the Lagrange's interpolation formula. So what are the notations in Lagrange's interpolation formula? The value of x, first value of x is denoted by x naught, then second is x1, the third value is x2, then x3 and x4. So in Newton's forward and backward, the first point is the first value of x is denoted by a, then a plus h, a plus 2h. But here the notation is what? Denote the first value of x by x naught, then second by x1, third by x2, in this way. Okay, so this 7 is x4, and then apply the Lagrange's interpolation formula for this problem. Then write the Lagrange's interpolation formula. So the values are what? Up to x4. So write only the formula up to x4. So what is the first term? Fx is equal to x minus x naught is not in this term. So what is the term? X minus, starting from x minus x1, x minus x2, x minus x3, x minus x4, divide by x naught minus x1, x naught minus x2, x naught minus x3, x naught minus x4. Okay. So these are the brackets into f of x naught. So In a numerator, there is no x minus x naught. So again, the second term is what? Plus second term. X minus x1 is not present in this numerator. What are the terms? X minus x naught, x minus x2, x minus x3, x minus x4. Divided by x1 minus x naught. Why the terms are up to x minus x4? Because the values are at up to x minus at x4. Last value of x is x4. So only the terms, last term is what? X minus x4. So don't write x minus x5 because there is no x5. So x1 minus x0, x1 minus x2, x1 minus x3, x1 minus x4 into f of x1. Then next term is what? The numerator does not contains the term x minus x2. What are the terms? X minus x0, x minus x1, x minus x3, x minus x4. Divided by x2 minus x0, x2 minus x1, x2 minus x3, x2 minus x4. That is just replace x by x2 into f of x2. Then this term numerator does not contains what? X minus x3. What are the terms? X minus x0, x minus x1, x minus x2, x minus x4. And just replace this x by x3 into f of x3 plus the next last term is what? X minus this numerator does not contains x minus x4. What are the terms? X minus x0, x minus x1, x minus x2, x minus x3. Divided by, just replace this x by x4 into f of x4. So we have the total 1, 2, 3, 4 and 5 terms. So the values of x or y are 5 in number and we have the 5 terms. So if these values are 6 in numbers, that is the values of x or y are in 6 in numbers, then we have 6 terms. If these values are 3 in number, suppose only this is the given table, here the only if the 3 values are given of x or y, then we write only 3 terms in the Lagrange's interpolation formula. So here 5 values are given and therefore we have the total 5 terms. So first, second, third, 4 and 5. We have total 5 terms because the values of x or y are in 5 in number. So, and then write the values of x. What is x? X is we have to find the value at 5, means x is 5. So right here correction that and x0, x1 and x is what? X is 5. We have to find the value at 5. Therefore, x is 5. So right here 5 minus x1 is this 2. Then write all these x as 5 and these x1, x2, x3, x4 and this x0. x0 is 1. And what is f of x0? F of x0 is 2. F of x0 is 2. Then write all the value. F of x1 is 4. This value. F of x2 is 8. So write here x as 5 and all the values, remaining values of the x0, x1, x2, xn. Then f of x0, f of x1. What is f of x4? F of x4 is what? 128. And so after calculating all these calculation, we have the answer 33.30. So what is the value of the function at 5? That is, what is f of 5 is 33. So observe this answer. The values of fx are increasing. So we know that what is your gauge? That the answer is greater than 16 and less than 128. So and nearest to 5 is nearest to 4. And so this value is what? 33.13 is nearest to 16, not near to 128. So next example on the same interpolation formula, Lagrange's interpolation formula. And this is the given table. Values are 5, 6, 9, 11. The values of x are not equidistant. We can also, if the values of x are not equidistant, then we have to use Lagrange's interpolation formula. But if the values of x are equidistant, then also we can use the Lagrange's interpolation formula. But if the values of x are equidistant and it is depend on v that formula is not compulsory in the problem, then we can use Newton's forward or Newton's backward. So if the values are not equidistant, then we have to use the Lagrange's interpolation formula. But if the values of x are equidistant, but in the question is use Lagrange's interpolation formula, then we can use the Lagrange's interpolation formula. So the values of x, this is x naught, this is x1, this is x2, this is x3, and what is x? X is 10. So instead of f, here is the notation y. So we use y instead of fx, and then values of x are 4 in number. So we have total 4 terms, 1, 2, 3, 4. And what are the terms? This numerator does not contain x minus x naught. Here is no x minus x1. Here is no x minus x2. Here is no x1 minus x3. X minus x3. So missing terms are what? X minus x naught, x minus x1, x minus x2, x minus x3. And write the formula for these 4 values. So these are the 4 in number. X values of x are, and so we have total 4 terms. And what is f of x naught is 12, f of x1 is 13, f of x2 is 14, f of x3 is 13. So substitute all these values, the values of x naught, x1, x2, x3, and x in this formula. So after calculation, we have the answer 14.66. This is the y10. So if we observe in the table, here is 10, and the value is what? The table, the values of y are increasing. And so value of at 10 must be lies between 14 and 16. And so what is the value? 14.66. The next problem, apply the Lagrange's formula to find the percentage of criminals under 35 years of age from the following data. So age less than, so less than 25, the percentage of criminals is what? 52. And less than 30, then if the age less than 30, then the percentage of criminals is 67. Below 40 it is 84, and below 50 it is 94. So this first row is the values of x, and the second row are the values of f, the function y or fx, and denote these values of x by x naught, x1, x2, x3. And what is x? X is 35, because we have to find the value corresponds to 35. And then write the Lagrange's interpolation formula for 4 values, similar to this problem. This is the formula that contains 4 terms. So write this formula and substitute the values. We get the answer 77.15. So here is the 35. So answer must be greater than 67 and 84, because the values of, if we observe, the values of y or fx are increasing, and that's why the answer is greater than 67. This answer is greater than 67 and less than 84, 77.15. So next problem, the values of x are given 5 in number. The values are not in equidistance. The values of x are not equidistant, and we have to find the value corresponds to 5. Then notation x0, x1, x2, x3, x4, and x is what? 5. We have to find the value at 5, and then write y or fx. Here write y or fx, yx or fx. Then there are 5 values of x or y, and therefore the 5 terms. So in this first term, there is no x minus x naught. Here is no x minus x1. Here is no x minus x2. Here is no x minus x3. And here is no x minus x4. So, and substitute all the values given in the table, and we have the answer 22.746. Similarly, the next problem, we are given the function of values of the log function, log 654 with base 10 is this. So what is the table? The values of x are 654, 658. These are the values of x. Don't write the values of x are log 654 with base 10. So what is x naught? X naught is 654. X1 is 658. X2 is what? 659. And X3 is what? 661. Okay. And the corresponding values are what? This is what? F of x naught. This is f of x1. this is f of x2, and this is f of x3. So write the formula. The values are 4 in number. So write the formula for if the values are 4 in number. So these are 5 values. Problem. So this is the formula. Write this formula. Write yx or fx is equal to this formula. 1, 2, 3, 4 terms. Okay. So write here this formula and then substitute the values. So what is LHS? F of 656. X is what? 656. So f of 6, 5. What is fx function? Fx function is log x with base 10. So f of 656 is equal to, and x is 656, right? x1, x2, x3, all these values. And this is f of x0. This is f of x0. Then this is f of x1. This is f of x1. And write all these values. We get the answer 2.8168. We can also calculate this 6.5 log of 656 with base 10 by using calculator. So use the knob of calculator, log knob, because log in calculator means with base 10, and ln, the notation ln is what? Ln means the base is e. So here is base is 10. So find, confirm this answer by using calculator. We can also find log of 656 by using calculator. So next problem is use the Lagrange's interpolation formula to express the function as sum of partial fractions. So what are the partial fractions of this function? In 12th, we can calculate its integration by partial fractions. So integration by partial fractions. What are the factors? A by x minus 1 plus b by x minus 2 plus c by x minus 3, and then find the values of a, b, c. But here we have to find the partial fractions by using Lagrange's interpolation formula. So what is the method? Write this numerator as a function fx. Let we denote this 3x square plus x plus 2 as a function fx. So this is numerator is fx. So here factorize this denominator. If the factors are not given, then obtain first factors of the denominator. So here factors of the denominator are given. If the factors of the denominator are not given, then you factorize the denominator directly or by using synthetic division. So here the factors are given, and then numerator is what? Is denoted by the function fx, and then prepare the table. So what is the first row? The values of x, and what is the second row? Values of fx. And we take the values of x as the roots of these brackets, roots of these factors, or roots of this denominator. So what are the roots of this denominator? 1, 2, and 3. If we find the root of the denominator, then we have the answer of x as 1, 2, 3. So these are the roots of the denominator. So write here values of x as 1, 2, 3. So in each problem, these x are not 1, 2, 3. So what are the x? The factors of the roots of the denominator. So what are the roots of the denominator? 1, 2, 3. So write x as 1, 2, 3, and find the value of the function fx at 1. So how we can find the value at 1 of the function fx? Substitute x as 1. So 1 square is 1, 3 into 1 plus 1 plus 2 is 6. Then find f of 2 by substituting x as 2. So 2 square 4 into 3, 12 plus 2 plus is 16. Similarly, substitute x is equal to 3 and we have the answer 32. So this is the table. Then apply the Lagrange's interpolation formula. So this is x0, this is x1, and this is x2. And then write the interpolation formula. So what is the interpolation formula? The values of x are 3 numbers. So we have total 3 terms, 1, 2, and 3. What is the first term? This term, this numerator does not contain x minus x0. Start from x minus x1, x minus x2, then x0 minus x1, x0 minus x2 into f of x0. This is, there is no x minus x1. Here is no x minus x2 term. And x0 is 1, x1 is 2, and x2 is 3. And what is x? In this problem, x is x. So don't write x as a number. And then what is fx? X minus 2, substitute all the value into f of 1. So what is f of 1 is 6. So right here f of x naught as 1 as 6, f of 1 as 6 in the next step, and substitute all the values. F of x1 is 16, f of x2 is 32, and we have this answer 3 into x minus 2 x minus 3. Here is minus 16 x minus 1 x minus 3, and 32 by 2 means 16 x minus 1 x minus 2. This is the value of fx, means this is the value of what? 3x square plus x plus 2. So and then dividing both sides by x minus 1 x minus 2 x minus 3. So what is LHS? fx divided by x minus 1 x minus 2 x minus 3 is equal to, what is RHS? 3 divided by x minus 1 x minus 2 x minus 3. So x minus 2 and x minus 3 get cancelled. So we have 3 by x minus 1. Similarly here divide by x minus 1 x minus 2 x minus 3, we have this. And also here divide by x minus 1 x minus 2 x minus 3, we have 16 by x minus 3. So these are the partial fractions of this function. So what is the question? Use Lagrange's interpolation formula to express the function as sum of partial fractions. So this RHS is what? Is sum of partial fractions of this function. So these are some problems to solve you. So solve these all problems, answers are given. So here we have to interpolate the value at 3. Values of x are given 0, 1, 2, 3, 1, 2, 4, 5. And we have to find the value corresponds to 3 by using Lagrange's interpolation formula. So similarly here we have to find the value, find the weight of the babies during 5 to 5.6. So 5 corresponds to 5, answer is 15. So we have to find the value corresponds to 5.6, and then what is the answer? That is f of 5.5, 5.6 minus f of 5, that is minus 15. So this is the answer, that is answer is 15.67. 15.67. This is the value corresponds to 5.6, and the weight of babies during 5 to 5.6 of life. So if we have to count this number, then apply this 15.67 minus 15, that is 0.67 is the answer of this question. Find the weight of babies during 5 to 5.6. So the answer is 0.67. So this is the answer corresponding to 5.6. Then we have to find the values of root 153. So what is x? So here remember that x is not root 153. X is 153, just right? X is what? 153. So don't take x as root 153, because the function fx is root x, and so here is 153. The values here, observe, the values are equidistant: 150, 152, 154, 156. So and we have to find the value at 153. Here is 153. So this problem is solvable by using Newton's forward, Newton's backward, and Lagrange's. But here in the question is use Lagrange's interpolation formula. So we can also, from this example, we observe that Lagrange's interpolation formula is also applicable if the values are equidistant. Lagrange's interpolation formula is applicable if the values are not equidistant, also if the values are equidistant. So, but the first two formulas, that is Newton forward and Newton backward, are not applicable if the values of x are not equidistant. But here the Lagrange's interpolation formula is applicable if the values are equidistant or not equidistant. So again, what are in this problem? X is this, x naught is this, x1 is this, and all the values we have to find 658. So x is 658. So in this example also note x is 153. Don't write x as root 153. Similarly, we have to find value at 2.5 using Lagrange's interpolation formula. Here the values of x are also equidistant, but the instruction is use Lagrange's interpolation formula. So apply Lagrange's interpolation formula. Then find a polynomial of degree 3 which fits to this data. So similar to Newton's forward backward, we can find a polynomial for the data. So what is x naught? X naught is this, x1 is this, x2 is this, x3 is this, and then write the Lagrange's interpolation formula and only substitute x as x, because here is the problem is of finding polynomial of degree 3 that fits to this data. So x is x, so write x as x and simplify, we get the polynomial. Similarly, solve the next problem. So answers are given. So the answer of that polynomial, finding third degree polynomial, is this, and just write, if you have to find polynomial using Lagrange's interpolation formula, then just write x as x. Then the problems of partial fractions. So here the factors of the denominator are given, but here the factors are not given. So factorize this denominator by using synthetic division, and we have to find the partial fractions. So here in this problem, fx is this, and what are the values of x? 1, -1, 4 and 6. So table is what? The values of x in first row are what? 1, -1, 4 and 6. So use the Lagrange's interpolation formula to obtain the partial fractions, and the answers are given here. And again, find a cubic polynomial which fits to this data. So we find the polynomial, cubic polynomial, 4 degree polynomial, 5 degree polynomial, which fits to the data. So we can also find the polynomials which fits to the data by using the least square method. So next chapter of our syllabus is fitting of polynomial. So in that fitting of in that chapter, we can find the polynomials which fits to the data by using least square method. So we can also find the polynomials which fits to the data by using Newton's forward, Newton's backward, and Lagrange's interpolation formula. But here the values, if you observe the values of x in this table are equidistant, and so this problem is solvable by using Newton's forward, Newton's backward, and Lagrange's. So the answers are given. So solve all the exercise.